Hello! Yes! Welcome to the final portion of our Objective 16. Now, Objective 16, remember, says I can solve a system of linear equations algebraically and use systems of equations to solve real-world problems. Today, we're going to focus on those real-world problems. If you remember in part 1, we talked about substitution, we talked about solving systems with one solution, no solution, and infinite solutions. And then we did some examples with that. We talked about elimination in part 2, did examples with that. And now in part 3, we're going to solve application problems using systems of equations. So here's some steps we're going to use to solve these problems. First step, identify what the problem is asking you to solve for. What is the goal of the question? What are they asking? What is our end goal going to be? Next, we're going to define our variables. And that normally is directly related to that step 1. What are they asking you to solve for? Because you're going to solve for the variables. We'll create a system of equations with the given information, and then we'll solve that system of equations. And it doesn't matter what method we use. We can use elimination, substitution, whichever works best, and then we'll write our answer in the context of the problem. It doesn't need to be a full sentence, but we do need to be able to, explain our answer. Just a coordinate probably isn't going to work here. So let's look here at number 1. A vending machine only accepts quarters and nickels. When the machine was emptied Friday afternoon, 325 coins were counted. The coins had a value of $56.25. How many quarters and nickels were in the machine? Wow. Okay, so looking here, a vending machine only accepts quarters and nickels, and we want to know how many quarters and nickels were in the machine. Well, that's going to be what we solve for, so let's have those be our variables. Q for quarters and N for nickels. So now let's set up a system of equation here. Now let's see, there were 325 coins counted. So that means if I add together all my quarters and all my nickels, Q plus N, I should get 325, because that's how many total coins there are. Now the coins had a value of $56.25, which means for each quarter, I got 25 cents. For each nickel, I got 5 cents. And that total is 56.25. Alright, now how many quarters and nickels were in the machine? Well, let's find out. How should we do this? We can use substitution or elimination here. Let's use substitution on this one. So, looking here with substitution, remember we're going to isolate a variable first. I see Q plus N equals 325. That means if I subtract Q from both sides, N will equal 325 minus Q. Alright, by subtracting Q from both sides, I get that. So let's plug that into this bottom equation here. So I'll have 0.25Q plus 0.05, and instead of N, I'm going to say 325 minus Q, and that will equal 56.25. Now, I do not know 0.05 times 325, so let's go ahead and pull up a calculator here. 0.05 times 325. 0.05 times 325 equals 1625. Okay, so 1625. So I'll say 0.25Q plus 16.25 minus 0.05Q, right, because we got to remember to distribute that 0.05, equals 56.25. So combine our like terms. So we will have 0.25Q minus 0.05 would be 0.2Q plus 16.25 equals 56.25. And I need to get Q all by itself, so subtract 16.25. So that would be 0.2Q equals 40. 40 divided by 0.2, 40 divided by 0.2. That's the same thing as 40 times 5, but we can do it on here just to make sure. 40 divided by 0.2 equals 200. Fantastic. So we'll say that Q equals 200. Well, what does that tell me? That tells me there were 200 quarters. Well, then how many nickels? So let's go back to that original equation that we used to substitute in here, up here. N equals 325 minus Q. Well, so N would equal 325, and what did we find Q to equal? 200. 325 minus 200, which means N is 125. So, now that we've found our value for the variables, we solved the system. We're not going to write a coordinate pair. We're not asking for a coordinate pair. They're asking how many quarters and nickels were in the machine. So I would answer that. I'll say there were 200 quarters and there were 125 nickels. And that right there is my solution. Fantastic. All right, let's try another one together. Let's look at number 2 here. The junior class at Free State High School sponsored a costume party. Each student wearing a costume paid $2, and each student not wearing a costume paid $5. 150 studies attended the event. I think that's supposed to say students. 150 students attended the event, and the junior class raised $489 from admission fees. How many students attended the event that were not wearing a costume? So first thing, identify what they're asking. How many students attending the event were not wearing costumes? Excellent. Okay, so they're not asking both, they're just asking not wearing costumes. So now let's define some variables here and set up some systems of equations. So let's say X is students in costume, and Y is students without costume. Okay, so each student wearing a costume paid $2 admission. Each student not wearing a costume paid $5 admission. And 150 students attended the event. All right, well, there's our equations. So if I add together all the students, X plus Y, then I would get 150. And the cost, $2 per student in costume plus $5 per student not in costume, totaled $489. All right, now we used substitution last time, so let's use elimination this time. Let's multiply this top equation by 2. When I do that, I would get 2x plus 2y equals 300. Alright, and since these x values are the same, I would subtract so that I would get 0x plus 3y equals 489 minus 300 would become 189. Alright, and then I would say 3y equals 189, so divide by 3. 189 divided by 3, I believe, is going to be 63. Let's go ahead and check here. 189 divided by 3. Sure enough, 63. Alright. Oh. So we find y to equal 63. And look, we're actually done there. Notice what they're asking for. How many students were not wearing a costume? Well, that's what y represents, 63. So in this case, we don't need to plug it back in to find x. They're not asking us to find both. They're just asking us to find the one. So y equals 63. So I will say 63 students did not wear costumes. And that is my solution. Fantastic. All right. Let's do one more together, and then we'll have you do some on your own. Number 3. This month, Chloe sold 75 figurines in 2 sizes. The large figurines were sold for $15 each. The small figurines sold for $10. the total amount of money received for the large figurines was the same as the total received for the small figurines. How many large and small figurines did Chloe sell this month? Ooh, this is a really good question. All right, so let's talk about how we're going to set up this system of equations. So how many large and small figurines? So we'll say L for large figurines. And I don't like using S as a variable because it looks like my 5. So we'll say X for the small figurines. Alright, now how many total did she sell? 75. So if I add together L plus X, that gives me 75. And then it says the large figurine sold for 15, the small figurine sold for 10. The total amount of money received was the same. Okay, so that tells me that she got $15 for every large, and that equaled the amount of money that she got for $10 of every small. That's a key, all right? So let's use that. Those are going to represent our systems of equations. They look a little different than what we're used to, but we can still use substitution, and we could use elimination if we wanted to move them around a bit. But let's do this here. Let's say that X equals, I'm going to subtract L, so 75 minus L. So let's plug that in. So that means that 15L equals 10 times 75 minus L. Alright, very nice. Good. So we'll say 15L equals 10 times 75 is 750. 10 times negative L would be negative 10L. And we're going to add 10L to both sides. So that tells me that 25L equals 750. Alright, divide by 25, divide by 25. What is 750 divided by 25? Let's find out on our calculator. 750 divided by 25 equals, oh, what do you know? 30. Alright. So if she sold 30 large, how many small did she sell? Well, let's go back to that original equation that we used to substitute. X equals 75 minus L. So I'll plug that. Now we know that L is 30, so X is 75 minus 30, which means that X is 45. Alright, so she sold 30 large figurines and 45 small figurines. Fantastic. Box our answer. Call it a day. Very nice. Okay. Why don't you go ahead and try number 4 on your own? Alright, go ahead and try number 4 on your own. Identify your variables, set up a system, solve it, answer in the contests. Let's see how you do. Go ahead and try number 4 on your own. Pause the video, and then we'll check it together when you're done. Alright, let's see how we did here with number 4. A school supply store sells individuals pencils and pens. 2 pencils and a pen would cost 55 cents. 2 pens and a pencil would cost 95 cents. How much would 1 pencil and 1 pen cost? Alright, so 2 pencils and a pen. So let's see, let's do x and y for variables. If you use different variables, that's totally fine. So we'll say x equals pencils, y equals pen. So 2 pencils, 2x, and a pen plus 1 pen is 0.55. 2 pens, so that'd be 2y, so 1x and 2y is 0.95. How much would 1 pencil and 1 pen cost? Alright, well, I'm going to use, let's use elimination. And if you use substitution, that's totally fine. Like I said, the method that you use to solve really doesn't matter here. But I'm going to multiply this top equation by 2 so that we have the same number of pens. So that means I would have 4 pencils and 2 pens, and that'd be 1.10. Alright, now let's subtract that bottom one. So x minus 4x is negative 3x. Plus 0y equals negative 0.15. So negative 3x would equal negative 0.15 divided by negative 3 divided by negative 3. And I find that x equals 0.05. So that tells me one pencil is 5 cents. Okay, now a pin. So if we know that one pencil is 5 cents, so let's say 2 times 0.05, I'm plugging this into that top equation, plus y equals 0.55, and now we can solve for y. So that'd be 0.1 plus y equals 0.55. Subtract the 0.1, subtract the 0.1, and I'll find that y equals 0.45. So that means one pin is 45 cents. And there we go. How much is one pencil and one pin? One pencil is 5 cents, one pin is 45 cents. Fantastic. All right, raise your hand if you struggled with that one and you're not really sure maybe where we made a mistake. Otherwise, let's do the last one here, number 5. Why don't you go ahead and give that a shot on your own? Go ahead and try number 5, and then when you're done, we'll check it together. All right, pause the video, try number 5 on your own, and then we'll check it together when you're done. Alright, let's see how we did with number 5 here. Thomas and Justin wanted to purchase some entertainment for their upcoming flight to Florida. Thomas bought 2 books and 3 magazines for $50. Justin bought 1 book and 4 magazines for $40. Assuming all books cost the same and all magazines cost the same, how much does a book and a magazine cost? Okay, so variables: B for books, M for magazine. Again, if you use different variable, that's totally fine. So, Thomas bought 2 books and 3 mags for $50. And Justin bought 1 book and 4 magazines for $40. Okay, let's see. Again, substitution or elimination would work fine here. It doesn't really matter. We used elimination last time, so let's do substitution this time. I see that 1 book, let's see, if I subtract 4m from both sides, I'll see that b equals 40 minus 4m. Now let's plug that into the top equation. So 2 times 40 minus 4m plus 3m equals 50. So we'll have 80 minus 8m plus 3m equals 50. Combine my like terms, 80 minus 5m equals 50. I can subtract 80 from both sides. Subtract 80, and I'll get negative 5m equals negative 30. Divide by negative 5, divide by negative 5, and I find that m equals 6. So that tells me it's $6 for a magazine. I can then plug that in here. So b equals 40 minus 4 times 6. 4 times 6 is 24. 40 minus 24 is 16. Fantastic. So we learned that it's $16 for a book, and it is $6 for a magazine at this airport. Fantastic. All right. Hopefully we're feeling confident. If we still have questions, please raise your hand. We'll be around to check you out. Otherwise, go ahead and do the check for understanding that's up on the board, and I will see you next time. This is Mr. Carter signing off. Hope you all had a great day. I'll see you next time.